Okay, good afternoon everyone and welcome. I'm glad to actually see somebody here. I was half expecting to come here and find I had an empty room to present it. I know I've seen some of you at the demo station, so some of this will be familiar with the stuff that I talked about during the demos. What I'm going to cover, in the first session I did on Monday, I covered like the architecture and how you set it up and configure IDash for CA7 and all that sort of stuff. And what I really want to do with this session is talk about how you set up the SLAs, what specifics there are relating to CA7 and some of the new functionality that's come in with the system. So usual information, so on. Welcome everyone. Okay, so as I was saying, this session is going to cover the usage of CA7 as opposed to configuring it, the usage of IDash for CA7 rather than the configuration and setup that I covered earlier on in the week. So I'll do a little bit of recap for those of you who weren't in my first session on a sort of an overview of the setup and the requirements if you need for it. And then we'll talk about defining SLAs for workloads running under the CA7 environment, how you set those up, what all the functions mean, and then how you go about monitoring those, and a little bit about SLA reporting, and then finish off with an overview of the specifics that have come in with the latest version of IDash. This went GA a couple of days ago, and is actually the version that I was demoing on the demo station for those of you who turned up. So, for CA7 IDash overview and requirements, first of all, what is it? This is always a good starting point normally. For those of you who may not be aware what IDash actually does, it's basically designed to deliver on your service level agreements. Now, they may be explicit service level agreements that you've got in contracts with your business units or your companies or wherever it may be, but more often than not, it's implicit type of SLAs, i.e. the business unit expects you to have the work finished by 6 o'clock in the morning because they need online systems up, they need reports produced, and so on and so forth. And what it does is apply analytics to the data of your job executions to aim to provide you with warning ahead of time about problems that you might hit. So it does that through predictive forecasting. It looks ahead and says, okay, given wherever we are within a flow of work, how much time is there left to complete, and how much time of all the jobs that are needed to complete? And am I going to actually complete in the time that we have left available from any point within that workflow? So it's constantly doing this predictive forecasting. It will automatically recognize any changes you may make to your CA7 environment. So if you go into the database and you add a trigger or you add a dependency or you change the due out time for jobs or a schedule definition and things like that, then that will automatically be fed into IDash and update IDash's model of the world. Okay, so that it knows when you've done those changes. It maintains its own set of job runtimes. In CA7, you have a average job runtime, which is fine, except for the problem that in most days of the week, that runtime changes. On a Monday, it might be quite a short runtime for a job, but on a Friday, you've got more data, and therefore your runtime of that job is a lot longer. So what IDash does is say, well, I'm not going to use the average runtime that CA7 maintains. I'm going to keep my own average runtimes, and I'm going to store them on a day-by-day basis, end of month, end of year, end of quarter, etc., so that it has a much more accurate view of what a Monday's run of work looks like compared to a Friday's run of work. And it then maintains that the current critical path of how do we get from this starting point job to the SLA-defined endpoint job, which path is the longest path in terms of average runtime, based on its own average runtime information. And it will update that, what's the critical path is, depending on all sorts of different things that may occur. For example, you know, you get job failures, that take an hour to get fixed. That may mean that some other path between the start point and the end point actually then becomes the critical path. And whenever any problem causes that critical path to extend beyond the defined deadline or within a risk area, then you will get alarms being generated from the system. Okay. So for those of you who hit on Monday, this is a repeat. The architecture for IDash connecting to CA7 is over on the right-hand side is the IDash system running as an application inside Apache Tomcat, sitting on some sort of host, and that can be a Windows server, Linux server, and as I was told on Monday, a Z Linux server. And it's connected through TCP/IP to a new component in CA7 called the CA7 server for IDash. The server for IDash replaces what used to be used, a component called Job Flow Monitor, or JFM for short. That was a big bloated beast that did lots of things. IDash, the server for IDash, is a cut down version of that. That's taken a lot of the extraneous activity out of that code and reduced the amount of overhead it takes. The server for IDash uses log records generated from CA7 as ENF log records, and that's the methodology by which all changes to your database, all status activity for jobs, and everything else gets shipped down to IDash. There is an initial read when you connect IDash of the CA7 database directly. As you can see, there's an arrow pointing to the various files that make up the CA7 database. And that's the initial load of IDash's own database of all your job definitions, all your dependencies and trigger definitions, or all of the calendar definitions you have, or schedule definitions you have for those jobs, etc., etc. So you have that initial seed data load into IDash at first connect time, and thereafter the ENF records that are generated from CA7 do the update to the system automatically and maintain the view of the world that IDash has. There are some minimum requirements for those of you who may be involved in installing this. So you need to have some level of PTFs in place. You need to do some changes to various statements in the CA7 initialization deck, the SVC no statement, UCC7 VTAM statement, and crucially, you also need to have CA Common Services installed and running at a minimum of release 14.1. Plus, you also have to have an ENF database for recording the events, because that's your recovery mechanism. And the ENF database runs on a Datacom AD black box database system, which means that if you haven't got ENFDB already for any other CA product, you do have to install a CA Datacom black box system to set up the ENFDB. You set up ENF with a definition that says we want these CA7 log records that CA7 generates to be captured, made active, recorded in the ENFDB, and made available to whoever wants them, which is the CA7 server for IDash. So that's the overview of the architecture and how it all works. If you want more detail, obviously, you can get the presentation I gave on Monday when CA makes them available. So let's now look at creating SLAs for a CA7 workload. Now, what I tend to do is utilize the CA7 web client with the GUI interface for CA7. This is available for any CA7 customer at no extra cost as part of your license. And within that, there is a forecasting function that gives you a nice pretty flow chart, as you can see on the right-hand side, of any given application when you specify the starting job, which has the SCHID definition, SCHID ID definition, scheduling definition associated with it. So it runs a forecast, generates, looks at all the triggers, dependencies, and so on, and builds this picture, which gives you a good idea of, we know what the starting job is, but where do I want my SLA? And usually it tends to be somewhere towards the end of that flow, although not necessarily. You can define multiple SLAs to break flows up into segments, so that rather than having something right at the end and you have 17 hours of processing in between or whatever it is, you might want to break that into segments so that you get alerts at partway intervals in case there are problems in the first segment that may not impact the end for quite a long time. Okay, so sometimes if you have really long flows, it's better to define multiple SLAs, breaking it up into segments. So some sort of operational knowledge of that application is obviously critical. You need to understand when is it due to be out? When should we be finishing this?
So could I do, so I can't do multiple, so I can do from the very beginning at the very end.
I'm sorry, say again. I can't.
So I can do one SLA from the very beginning of that flow all the way to the end of that.
Well, you can. The SLAs actually works backwards. Okay, so if you define your SLA at the end, it will calculate what the beginning job is automatically, and that's where you put it. However, if that chain is very long, it may be that you have enough slack time that problems early on in the flow may not actually give you an alarm that you have a problem because you've got flexibility in that flow. So often it's better to define one at the end, and if you've got a long flow, also define one job in the middle. So for example, if we look at the flow there, we can define one right on the bottom, but halfway through where we've got like a pinch point where lots of jobs come in, you might want to define a SLA on that job, and it will go back to the same starting point job, but you then give it a different deadline time. And we'll talk about that as we get to deadline times. Okay? Generally, deadline times are defined by the business unit or the application team who maintain it, because they're the ones who know when the work should be finished. Okay? If you don't have the web client, then use something like fjob command within CA7, which will give you the text look back, or the text forecast information about the flow to give you some idea of where you want the SLAs to be defined. The other good practice is to use good naming conventions for various reasons. One is that obviously you want your SLA names to replicate or to be something that people will recognize. It's a finance application, it's my accounts payable, it's my accounts, some sort of accounting system, or it might be a warehouse update system, whatever it may be, but make it recognizable. And also try and use names where it makes it easy to group them. And we'll talk about grouping SLAs later, and by having simple or common names, it makes it much easier to find them. You can do searches on those names based on wildcards. Show me all jobs, all SLAs defined beginning with the name finance. It gives me a subset list so I can easily select them for grouping. Okay. So that's some good practices in terms of creating it. So having looked at our flow, we figured out where our endpoint or midpoint or whatever it is that we want to go and define SLA. The next thing we need to do is find that SLA job within the IDash system. So you go into the catalog tag menu item at on the top there and select SLA definitions, and it will give you by default a list of every single job you have in the system. Okay, which is, you don't want to scroll down 55,000 jobs trying to find the one you want. So you can type in either the whole job name or some part of a job name with an asterisk as a wildcard to reduce your list of searchable entries. If you know the exact job name, just type it in and it'll give you one entry to select. So then you have, as you see here, a list of, in my case, 7 jobs. I select one of them, and you click on the Create SLA blue icon, blue button up on the top right. And what this will give you is create a SLA page. So good naming conventions, like I said. So in my case, as you see, I'm using finance, and it's rolled credits, and the name of the actual system name from CA7 in my case, FinPRC, and it's a daily one as opposed to a weekly one or a monthly one. I may have several, so I may have daily _01. You're not allowed blanks in your name, so I use underscores instead of blanks, okay, which breaks it up so that all the words don't run together. So you might have _01 or _02 if you're using midpoint SLAs within the same flow. Give it some sort of description. And then, because you specified the endpoint job, and it's got a complete picture of your database, all the jobs all the way back, it automatically works out what is the starting point job. And what it's looking for is the job that has a schedule definition against it. Okay? So it will search back and it will find the scheduled job that begins that flow, some sort of usually often a non-exec job within CA7 terms that has a schedule associated with it and does nothing but just kicks off the chain. Okay? Now, just go back a second. Also down here you'll see there is a triggering job SCHID ID, okay, i.e. the version of the schedule. And you get that by when you click on the triggering job radio button over here. If you have a flow of jobs that doesn't actually have a scheduled starting point, right, for whatever reason, it may be fired off by a dataset trigger from an FTP coming in, then you can't use triggering job as an option because there is no triggering job. What you have to do is start using the run days of week and specifying that this runs on a Monday or a Tuesday or a Wednesday or whatever day it is. No, I'm fine, thank you. Okay, so it automatically identifies the scheduled job. However, in the earlier versions of IDash, it required you to specify the exact SCHID ID. Okay, so here's the scheduled job, but if I have, as some companies do, they use different SCHID IDs for different days of the week, for the end of the month, etc., etc. Okay, so it's the same set of jobs, but they run them under SCHID ID 1 for Monday, and they run them under SCHID ID 2 for Tuesday, which made it hard for them because they had to set up one SLA definition for each SCHID ID. Okay? So what we brought in was the concept, as we all know in CA7, the ability to say it's SCHID ID 0, i.e. it's any SCHID ID, any version. And we use that on triggering and dependencies a lot. Okay? So any SCHID ID run of this will trigger that. So in this case, what this says is, I don't care what you're running it with, I'm going to track those jobs under this SLA, regardless of whether they're running on SCHID ID 1 or 10 or 5 or whatever. Now, if you have different SCHID IDs for ends of month, then you might want to have specific SCHID ID, SLA definitions for those end of month ones because they may include lots of other jobs. Okay? It does provide more flexibility. So if you want to specify SCHID ID 0, you don't select the trigger job name that shows in the list. You select the option of all. Only if you select the option of all can you select SCHID ID 0. If you select the specific job, you have to select the specific SCHID ID number. Right, so now we've set up the chain, if you like. This is the endpoint job. We know what the starting point job is that we're going to use to make this flow up. Now we have to say what are we going to do in terms of deadline times. When is it due to be completed? And this is based on the last job, i.e. the job you specified the SLA against. And first of all, so you need to specify a time in hours, minutes. Now, strangely enough, you can specify hours, hours, minutes, minutes as greater than 24, which sounds odd. If you specify a time period which is less than 24 hours, so if I say 23:59 or 0800 or whatever, that assumes it's within the same day. Okay? The whole flow from the start job to the end job is within the same day. Okay? If, however, like a lot of sites, you have work running overnight, and the starting point job starts at 7 o'clock in the evening, and the end point job finishes at 4 o'clock tomorrow, the next morning, then you're crossing a boundary. Okay? And the way you tell that on the SLA definition in IDash is to add 24 hours to the deadline time. So if I have a deadline time of 4 o'clock in the morning where the starting job starts before midnight, I would specify a time of 28:00. That means it's 4 o'clock in the morning on the next day after the start job. Yep. If you say 0400, then it'll start thinking about tomorrow and you'll get all sorts of weird results happening. Yep. You need to add, it is documented in the manual, but not everybody sees it. There's a section about what you do if you cross boundaries. So as long as the whole flow is within the same day, you use somewhere between 00001 or 01 to 23:59. The moment you go across a boundary, you've got to add 24 hours to whatever the number is.
So Bill, that'd be even if your starting job started at 23:30, you do the same thing too.
Correct, yeah. If your job starts 23:30 and finishes at 5 o'clock, it's 5 o'clock to midnight. So that's 5 hours plus 24. Doesn't matter when your job starts. It can be any time in the previous day that the starting job kicks off, but you always add the 24 hours to it. If you have a flow that happens to span more than a day, you can specify, add 48 hours to it. So if you have a job that starts on a Wednesday, a flow that starts with the first job on a Wednesday, it runs over midnight into Thursday, carries on going, and the end job SLA finishes on a Friday, you go back to midnight. So how many hours from the deadline time, 4 o'clock to midnight, that's 4 hours, plus then 48, because you're across 2 days. Okay? Most sites don't have flows that run across more than 24 hours, okay? But they do often have flows that run across a boundary, a midnight boundary. So you usually add 24 to whatever time you want. Okay? So your choices are, if it's all within the same day, set the time as a normal deadline time. If it's over a boundary, add 24 to whatever time you have. So the next field then is, actually I've skipped over one by mistake. I should have had a little thing in here. In between the deadline time and the start tracking time is the type of SLA you want to generate. The default is end. And what that means is the completion of the SLA is considered at the end of the job that you specify the SLA for. Okay? There may be an occasion when you want to use start, but I can't think why. But some people may want to do that. But so the default is normally the end of the job that you're defining the SLA to is considered the end point of the SLA flow chain. Okay? When do I start tracking? Okay? Start tracking means, when am I going to make the flow visible within my list of SLAs? Okay? And there is a default setting that is set up within IDash itself for forecasting, etc., etc. So you can just leave it to say default, and that is whatever it's set to, 24 hours or whatever it may be. Okay? If, however, you don't want them to come in 24 hours in advance because you start getting too many SLAs showing and so on, you can specify a period of time back to for when you want to start tracking. Now, this is taken from the deadline time backwards in terms of minutes. So let's go back to our example. We have an SLA flow that starts at 10 o'clock at night and finishes at 4 o'clock in the morning. Okay? If I want to start tracking that at, say, 8 o'clock or 6 o'clock in the evening, okay, so that it's not there for 24 hours, it only appears in my list of SLAs at 6 p.m., then I need to say, okay, my deadline time is 4 o'clock in the morning, so I've got 4 hours back to midnight. I've then got 6 hours to 6 p.m. the previous evening, so that's a 10-hour total, times 60, that's 600 minutes. So my start tracking value is 600. Okay. The next one is how long to continue tracking after the deadline. Okay. The default is 60 minutes. I tend to think that's a bit short. Okay. I tend to set mine to either 120 or 180. And what this means is that if on the occasions when your application flow has a problem and runs beyond the deadline time, you still want to track those jobs so your SLA is marked complete all the way through to the end, even if it missed the deadline. Okay? And you capture all the job information about those jobs that carried on running in the flow after the deadline time. If you think 60 minutes is enough, fine. I tend to think 120 would be better, or possibly 180. So let's keep tracking the work. Even though we missed the deadline, we still want to know that that SLA and flow of work is completed. Run validity and the next field along, which is past hours, are more relating to when you're have an SLA on an application that runs multiple times in a day. Okay? Because if you leave that as default, what happens is that if an application can run in the morning and then run again in the afternoon, and you have two SLAs for that, and unfortunately, because your run validity is any period, it covers any period, it ends up picking up the morning's run and marking your afternoon one as successful. We were hours in advance. Okay, which is a bit confusing. So where you have multiple flows, multiple runs of an application in a day, you want to create a window of time that the jobs running in this window of time are valid for this SLA. If those job names run outside of that window of time, ignore them. Don't use it to mark my jobs in my SLA as completed or run. So you specify a run validity again in a number of minutes back from the deadline. Okay? So if my deadline is 4 a.m., my jobs are running between 10 and 4, I'd probably want to have run validity set to something like the same amount, 600 minutes, 10 hours, so that if I have a run of that same application starting at 10 in the morning and going through till 4 in the afternoon, I'm not picking up any job-related data from that early morning run. Okay. And associated with that is number of past hours. Your past hours should always be at least the same value in hours as your number of minutes for run validity. So if I say 600 minutes for run validity, I need to be tracking the work for 10 hours. Oh, I did put it in the wrong place. Okay, so default SLA job type is end, as I've talked about. Because of that, and somebody made a good point actually when I did a demo of this earlier on in the demo station, and they said, well, if the default is end, why not turn off the start alerts? And I thought that's a good idea, because when you say I want to generate alerts, you have to actually click on the blue button on the far side to expand the alert thing to say I want to generate alerts. But when you do that, they're all turned on. The 3 start ones and the 3 end ones. And his point is, well, if I'm setting it on the end, surely I only want the end alarms. And I can see there may be a reason why you want a start, possibly. But if you are doing it on end, then your alarm should be on the end. If you set the type to be a start type of job type end of deadline, then have your start alarms on. Right? But as it happens, they both turn on, so I always go and turn off the start ones, because I don't want 2 being generated. Okay, I only want 1. So you basically it will come up and have them as on by default, and turn off the start ones. And the 3 that you have are, you're going to fall into an area at risk, which I'll talk about in a moment, because I think I've skipped over that. Yes, I did skip over that, didn't I? Okay, I'll talk about that in a second. So you've got an at-risk alarm. There's a period of time that you consider to be a warning period. I'm getting close to my deadline. I'm not missing it yet, but I'm getting close to it. If it falls within that period, I want to know about it, because it's getting too close to the deadline and I need to try and do something about it. Then you have a predicted miss alarm, and this says, well, in my calculations, my analytics of how long this flow is going to run, my calculation is the last job is going to finish after the deadline. Now that may change, because jobs may run shorter than the average runtime that IDash is maintaining, and so the end time comes back. Okay? And therefore that predicted miss may go away. And then there is the missed one, and if you've got the missed one, that's it. You've already passed the deadline and the flow hasn't finished, so end of story. All right, so I didn't actually cover that for some reason. I don't know why. Okay, I skipped over that. In between those 2, end tracking and run validity, is an at-risk warning, and that's the number of minutes prior to the deadline that you're going to consider this to be a warning period. So that if the prediction is the end job, it falls within that 15-minute, 30-minute, 1-hour period, whatever it is you set, then you want an alert generated so that you can start looking at this and saying, why is it getting so close to the deadline? I generally set mine to either 15 or 30 minutes. Not too much slack, but a little bit of time, so that I can try and fix the problem if that's, and bring it back. And the thing is, we're predicting this, remember? So it may be that, you've got 400 jobs to run, and you may look at it and think, well, actually, I know that these jobs are going to run slightly less than that, therefore I can ignore it. Or it might be, well, I've got 400 jobs to run and I'm already within this 30-minute window. Hey guys, we need to look at this application and try and figure out why it's getting so close to the deadline. Okay. A new thing that came in with CA7, IDash 12.0.01, which is the previous build to the one that's just gone GA, is a thing called CA7 Job Links. And CA7 Job Links are a pseudo connection that's only known within IDash. Okay? Nothing in CA7, but what it does is allow you, there are normally two different reasons why you might want to use that. One is that I have a dataset connection between 2 applications. I have this application over here, and it runs and creates some dataset, and that dataset is used as a dependency or a trigger in another application. Right? IDash doesn't see that connection between of datasets. Okay? So by setting up this pseudo link, you're emulating the fact that there is a link based on a data set between this application here and that application over there. So that runs of work within this other application or jobs in that other application may impact the SLA in this application that I'm setting the SLA for. So I may want to connect two different applications through a job link. The other reason why it's used is where you have two schedulers, a mainframe and a distributed scheduler. And there's quite a lot of companies that have CA7 on the mainframe, AutoSys on distributed. So you run a chunk of work on the mainframe, and then at some end point of that, you kick off, you have a connection across to AutoSys, some mechanism, direct trigger or file or whatever it may be, and you run a chunk of work in AutoSys, and then you come back to the mainframe and you carry on running some more work in the mainframe. Okay. At the moment, IDash does not support cross AutoSys CA7 SLAs. Okay. It's coming. It will be available in the future, without saying when, we don't know. But at some point we are going to build that functionality in. However, in the meantime, there is no way that you can connect the two bits of the CA7 workload because you've got this stream of work in AutoSys in between. So the way you do that is to make a link between the last job in the first segment on CA7 and the first job in the second segment in CA7. Now it can be a lot of work if you have a lot of back and forth between CA7 and AutoSys. So if every other job is CA7 2 jobs, AutoSys a job, CA7 3 jobs, AutoSys a job, that doesn't work because you just have too many links to set up and maintain. But where you've got relatively solid chunks of work and it's only back and forth one or two times, then you can use job links to emulate the connection that AutoSys work is doing. Okay? Now we'll try to take into account the fact that that link actually takes a length of time because there's the chunk of time that's running in AutoSys. Okay? And it will, from what I've seen, it seems to learn that this next chunk of work isn't going to start until an hour and a half later. So it gets quite good at doing that, okay, given history and so on. And then you'd obviously have a separate SLA in IDash for the AutoSys piece. And you can use, there are two options to these job links. You can have a trigger type or a dependency type. To be honest, I haven't figured out what the difference is. The slight difference is in the definition, but I can't see how it differs in the way IDash processes and does SLA critical path analysis. Yeah. It may be around SCHID IDs and things like that. I'll have to investigate some more. So there's a definition of a trigger type. You specify the instance, the job, SCHID ID, and what is this link effectively going to be connected to trigger? And the other way is from a dependency job, what is the predecessor job that's going to release me? And here's an example. There is actually a dataset connection on the yellow job. I have a dataset connection that connects the three green ones at the top to the yellow one. So there's a dataset dependency there, and what I've done is I've put a job link in between those, between that chain of three at the top and that one in yellow, and it shows up just as a normal connection in the SLA critical path flow. It doesn't show up any differently. You can't click on it and it won't tell you it's a job link or anything like that. It just is another connection that just happens not to be in CA7 itself. So that's defining the workload. I have to get a move on. I'm running late. So now we're into monitoring. Here we have the consolidated dashboard. So this summarizes your total information about all of your SLAs that you've defined. You've got a list with numbers on the left-hand side and a donut shape which shows you graphically the number of SLAs of various stages. If you click on the colored circles by the list on the right-hand side, it will switch on and switch off the entries in the donut. So if I'm not interested in all my SLAs that have been met, the light blue ones, the 10 of them or whatever, if I click on the little round circle next to met SLAs, that will disappear out of my donut. So I'm left with ones that are on time, ones that are predicted to miss or at risk or missed. You have the ability to define a personalized watch list. And this is basically a filter on your list of SLAs. You can define tags, and those tags have a name, and you can select which names you want to have visible in your watch list. And that tag has a selection of SLAs that somebody has to define against that tag. And this is unique for each user. This is your own personal user watch list. You can have multiple tags that you're watching, and tags can have subtags within them. So if I drill into one, I can get additional buttons that give me a finer selection within that set. And you use the little pencil icon to customize what tags you're going to show on your desktop, on your dashboard. Right. All alerts that are generated are generated within IDash, and what you'll see is the last 10 alerts in a list on the right-hand side. You can expand one, and it will give you details about the job, the SLA, start and end, when it occurred, and so on and so forth. Also, when you get an alert generated, it will have a red line against it. It's a newly generated one. And the watch list group will have a red line against it because you've had an alert on an SLA within that group. Now, you may have multiple groups have red lines against them because that SLA may be actually in multiple different groupings or filtered tags. Having drilled into the SLA tag, the watch list tag, you'll get a selection list. This is actually from the slightly earlier version. The sub-tag buttons at the top, which are very big on here, have been made much smaller in the latest GA version, which is really nice because it doesn't take up as much room. You get more entries in your list, and it's actually a much cleaner implementation. But unfortunately, I had to create this presentation several months ago, and I didn't have the latest version available at that point in time. So what we get is a filtered list. As I said, you can have subtags, and then you have individual entries, and that's the one that came at risk in the alarm as I showed on the dashboard. I can drill into that by selecting the SLA, and when you select the SLA, it'll actually go to the summary entry first, and that will actually show you the history of that SLA. And in the current release, it will also show you a list of problematic jobs. And a failed job is considered a problematic job. So in the summary view, you'll get the fact that this job has failed. What I've selected here is the flow view, which shows me the critical path, and it shows the fact that we do have a failed job. It's got a red X in the middle. All failed jobs will immediately put an SLA at risk, even if they're not in the critical path chain. So you can then go in and try and figure out what's gone wrong, correct the problem, and hopefully sort it. It shows up as appended. You can click on the job name when you've selected the job, like I have here. You can click on the job name, which is actually a link, and that will take you to the details about that job. It shows it's appended, how long it ran for till it appended, and also, crucially, what other SLAs may be impacted by that job. Because you may then get other SLAs generating alerts because they're all connected back to the same appended job. As I say, it does show as appended. Okay. And now we've gone into CA7, we fixed the problem, we restarted the job through CA11 or whatever, and it's now running, and it goes to a nice clean circle with an arrow in it, a forward-facing arrow that says this is the job is now executing again. However, the SLA is still at risk, and that's probably because the delay in the time that it's taking you to fix the problem has meant that the prediction still thinks it's going to run that job over the end of the, or to getting close to the deadline time. And you can look at that by going into the time view. There's the job that we reran. Here's the current timeline. This is where we are at the moment. And our risk time line is that yellow one over on the right-hand side. And the yellow shaded area is the bit that is your at-risk period. And it now shows that the last job is actually ending within that at-risk period. And the black line in the middle there shows when the SLA is due to complete based on our predictions. And the red line is the actual deadline time. That's what you specified. And beyond that is my continued tracking line. That's the period that I said I want to carry on tracking this work even though I may have missed my SLA deadline. At some point you'll get through and hopefully it met the SLA, work ended up running through quicker and we ended up with it meeting the deadline, which is pretty good. Because some later job ran in less time. So what that meant is it pulled it back. In 12.01, the previous one to the GA, we also brought in the visibility of datasets. Okay? And what datasets do is show us triggers or dependency type datasets. We don't know when they're going to arrive, but we know that they could have an impact on your SLA. So that if you do get an alert because you've got, you're into the at risk, you go into the flow view, you see there's a data set, you can click on that data set. You'll get the CA7 dataset name and dataset number, and you'll be able to go and find out, is that the cause of what's impacting my SLA? The fact that this dataset should have been created and the FTP hasn't worked, or it's late, or whatever. Whilst we can't do much about it, it's visibility of the fact that it's there and has could be impacting the SLA. Final bit is reporting. There are only a couple of reports in the IDash system relating to CA7. There is a CA7 Job Run report and an SLA trend report. The Job Run report, to be honest, I don't think is very useful. You can get better reports out of CA7 itself in terms of all your job runs and so on and so forth. But the SLA trend report is the most useful one. You can get it as summary or detailed versions, and you define a report definition and save that report definition and then dynamically create it whenever you want. And the report definition will say, I want to look at SLA trend for the last 7 days, the last 30 days, whatever it may be. And whenever you issue a download request, it will generate it for that period you specified. So we have a list of reports. I've selected, you select the SLA trend report. And it says here we have a trend report for all SLAs beginning with the name Fin. Good naming conventions. And we want it for a time frame of 31 days. And what we get is an aggregate performance of my SLAs. There's my SLA names at the bottom. This is how many times that SLA has occurred in the period I've specified, and that's how many times I've met it or not met it. The red is I haven't met it, the green is I have met it. So generally, these SLAs are looking pretty good. I've had a few failures on each, but otherwise they're okay. This one is on a time basis and is used to say, over this period of time, I had X number of SLAs active. How many of them finished green, i.e. on time or ahead of time, and by how much in that period of time. Now in this case, I didn't have the period I've got this report on, didn't actually have any failures. If I had ones that didn't meet the deadline, then the time period would be in the middle and I'd have green above and red below. And that would be the green would be how many minutes ahead of the SLA deadline I completed those SLAs, and the red ones would be how many minutes past my deadline did I fail to meet them. 1202, the latest one, brings in a few new features. First of all, for those customers who are running CA7 and AutoSys, okay, we've added authorization of EAM, including CA7 users. You can add your CA7 users into EAM, which is the AutoSys authentication mechanism, because not all, by default, if you only have CA7, the authentication is on CA7. But if you have a mixed environment, not all of your distributed users may actually be authorized in the CA7 environment. So you have to add your CA7 users into the EAM environment and then do authentication through EAM. You can also use LDAP, an LDAP system. We've added support for conditional dependencies and negative dependencies, which are special functions within CA7. We've also improved the loading mechanism when we're building a flow view to do it on an incremental basis. Where you've got very large critical path flows, it was taking such a long time, we're now trying to improve that by loading on an incremental basis. You'll get bits of it appearing. That's it. Any questions? Must-see demos, you've already come and seen them. So thanks very much. Hope you enjoy this evening's event. I'm sure I will be. We finished. This is pretty much it now, so I'm between you and the event tonight, so I'm conscious of that. I'm looking forward to it as well, because it means I've finished my work for this week. But it's been a pleasure to have you all around, and thank you very much.
Thank you.